Okay, let's get started here. Okay, we're going to get started into the joy of diagrams. Today we're going to be making the greenhouse effect and carbon. And what we're going to start with is um, our Earth. And so I've putting in some different squares and some different circles to show our Earth. And so our Earth is going to, let's see here. The Earth is going to look like we're going to have a hill in there and another hill on our Earth. And then I'm also adding a title called Greenhouse Effect and Carbon. I'm going to add in other hills. I'm going to add some more hills. So I'm going to fill up the bottom of my paper just with some beautiful, lush green hills that are doing photosynthesis. And I'm also going to add in at the bottom, I'm going to add in a layer of Earth's crust. And I'm going to have Earth's crust be in there to show that this is planet Earth. And I'm also going to add in a river and then an ocean because we can't forget that the Earth is 71% water. 71% of our planet is water, and so that's going to include our rivers and our lakes and even an ocean. So I'm going to add in an ocean to our scene, and I'm going to add in some sea creatures. And I can choose whatever sea creatures you would like to add in. It could be a shark, or you can put in little fishies. Your imagination is limitless. You can have a sea otter, if you will. Whatever you choose, it's up to you. At the top, we have greenhouse effect and carbon. So it starts with planet Earth. And with planet Earth, um, we're going to show Earth's crust. We're going to show the rivers, and we are going to have an ocean. So at the beginning of our planet had volcanoes erupting. It had wetlands, and when life first began to appear on the planet, life began to take in um, carbon dioxide and began to take in water. And the first life that appeared on our planet was plants. And as plants began to take over our planet, they began to emit carbon dioxide as waste. And carbon dioxide as waste was very helpful for our planet because the carbon dioxide would go into the Earth's atmosphere and it would begin to create a blanket and hold in the sun's energy. So it really had a protective layer of gas on our planet. Also, adding to the carbon dioxide on our planet was natural resources like a volcano and wetlands and termites. And these natural phenomena would release carbon dioxide into the atmosphere. Um, and so this would be helpful to help warm up our planet so that it could support other forms of life like animals and then later on humans. And so I'm going to draw an arrow here and show an arrow that will go up into the atmosphere, and it'll be CO2. And so I actually drew the molecule where it's one atom of carbon and two atoms of oxygen that make CO2. You can choose to make that molecule if you will, or you can just write CO2 if you would like. This is yours. This is your diagram. And so I'm providing a model for you to use. However, you can add to yours to make it better, or you can make it so that you understand it, because this is really for you and your understanding of greenhouse effect and carbon and how that works. Carbon comes in many forms. It can come from inside the earth in the form of minerals and coal. It's also can come in the form of plants as glucose. And then it can be rearranged into carbon dioxide and released as a gas. So carbon can be a solid, and carbon can also be a gas. And on our planet Earth, these hills are going to represent all the plants doing photosynthesis. And as those plants are doing photosynthesis, they are releasing carbon dioxide. Also, they release carbon into the planet in the form of organic matter decay. And as the plants die off, they're going to get decayed and they're going to smush down into our planet. And more plants are going to grow on top of them, and they just continue to get smushed and smushed and smushed and packed on top of each other. And this is going to make decaying plant matter. Another source that's a natural phenomenon is the burning of biomass. And the burning of biomass will release carbon dioxide. One of the other things that our planet releases naturally from wetlands and the decaying plant matter is when the plant matter is decaying, it'll also release this thing called CH4. It's a molecule called methane. And this was in our reading on the cheeseburger footprint on methane. And this happens naturally through the decaying of plant matter. As plant matter is broken down, its carbon inside the plant matter gets rearranged into a gas form called CH4. And that is one atom of carbon and four atoms of hydrogen. And it is a gas that goes up into our atmosphere. And so I drew it specifically with an arrow going up into the atmosphere where you have CH4. I was talking about the burning of biomass, and biomass is any plant, any organic material that grows from photosynthesis is called a biomass. And that could be in forests, that could be trees, it could be shrubs, it could be bushes. Any of the plants is called biomass. And so the reason why I show burning biomass is because this is an important part of the growing of our greenhouse on our planet, is releasing more gas into the atmosphere happens. So over millions of years of lightning strikes hitting a tree, and the tree can catch fire. This could be a forest fire. This could be burning. And I showed burning biomass here of flames and fire, because as this happens, this is going to release smoke, and in that smoke is CO2. So the smoke goes up into the atmosphere, and it's going through a chemical reaction. So fire is burning the wood, the limbs, the trees, and so all of that is releasing now carbon dioxide, and the carbon dioxide would go into the atmosphere as well. Now, this can happen naturally, or what's happening more often on our planet is, as farmers are seeing that there's a higher and higher demand for beef, because more and more countries are eating more and more beef, and Americans are eating more and more beef than ever before, they need to raise more cattle. And as they raise more cattle, they need more land to raise their cattle. And so unfortunately, what's happening in South America is that Companies are buying forest lands and they are burning the forest to clear out the forest. So they'll burn down the forest. And this isn't any type of forest. This is rainforest. So highly dense biomass. They're burning it down and then they're taking out all of the material, and then that is turned into pasture for cattle or cattle homes to be raised for cattle. And this is happening in the Amazon rainforest in Brazil. This is happening in Colombia. It's happening in many of the countries in South America. Companies are taking the forests and they're burning the biomass to give way to raise cattle. This is happening a lot because there's a high need, and so beef is very expensive. And so if the forest is just there, let's just buy the land and we'll burn down the forest and we'll raise our cattle on it. So not only is that releasing carbon dioxide by the burning, is now you're raising more and more beef, and there are more and more cows, and the more and more cows are giving way to more and more methane. And so let's add in a really nice picture of we're going to add in a really nice picture of livestock. Also, I want to add in another thing really quick, though, is to show that the rivers and the oceans are a part of the water cycle on our planet. And so the waters and the rivers are not only do they do release a little carbon dioxide, but they take part in the evaporation of water vapor. And so as water vapor evaporates, it goes up into the atmosphere. And so I drew a little water molecule that represents H2O, and H2O goes up into the atmosphere, and the H2O will hang out in the atmosphere for a while in the form of it doesn't always have to be clouds, it can just be in the atmosphere. But if there's if it begins to collect, if there's more and more H2O, it collects to a dust particle, and the H2O will stick it, and there's more H2O, and it sticks to it, begins to make clouds, and the more and more clouds there are, becomes more and more H2O, and then eventually that water will fall back to earth in the form of rain or sleet or snow, just depending. And so that's the whole water cycle that you probably learned about in 5th or 6th grade. So I'm just going to show H2O floating up in the atmosphere. And that's why I have 3 different molecules of H2O floating up in the atmosphere. And they're floating so peacefully, just going as a little water vapor molecule floating in the air, not hurting anyone. I think I'm going to add a little bit of livestock to the hills, on our other hills there. And I like sheep a lot, so I've added 2 sheep in, and I've added 3 cows because there's people like to eat beef more than they do like to eat sheep. So I put in 3 cows there of livestock and have my livestock there. If you wanted to add, more cows, you could. It's up to you. If you wanted to put a fence around your cows or a barn, you could add a barn. So I have my 2 sheep and my 2 dairy cows and 1 bull cow just hanging out on the side of the hill, grazing, eating grass. So beautiful. And as they eat the grass, they go through the digestive process. And a part of the digestive process is that they are going to release carbon dioxide and methane. Now, that's a natural phenomenon. However, as humans have more and more demand to eat beef, and as our future food, thinking about the demand of beef is really high, that means that there's more and more livestock on our planet releasing more and more methane gas and carbon dioxide. And as there's more and more, that means that there's more and more greenhouse gases in our atmosphere. So I'm drawing an arrow to show that the livestock are releasing methane into the atmosphere. Methane makes up a small percentage of our atmosphere. And this isn't necessarily a bad thing, because without greenhouse gases, we wouldn't have a very thick atmosphere. And the importance of the atmosphere is that it is going to lock in the heat from the sun for our planet. And that's a really important part of our process, because without the greenhouse gases, it wouldn't make our planet too cold, and it wouldn't have life on our planet. It wouldn't be habitable. Our planet would not be habitable. However, our human impact, as you're going to begin to see, is changing how many greenhouse gases are on our planet. So as more and more humans are on our planet, and we're eating more and more food than ever before, we have to throw away all our packaging. And so humans decided, let's dig a big hole on our planet and let's throw all our trash into the holes. And these holes are called landfills. And landfills are big piles and piles of trash. And once a landfill gets kind of filled up to a certain point, the people will then put dirt over the landfill and pretend like it's not there. Parts of San Francisco are built upon landfills. And in the early 1800s, parts of San Francisco, they would throw their trash out in certain areas, and then they would cover it up. And over in time, as San Francisco grew, they decided to put streets and plumbing over the trash. And I don't know if you remember back to the earthquake unit that we did, but was that a good idea? No, because lots of parts of San Francisco crumbled in the different earthquakes that we've had, because the ground wasn't very stable. It was filled with trash, decomposing trash. So landfills, as organic material decomposes and decays, the bacteria that is feeding on the material is giving off high amounts of carbon dioxide and methane. So methane and carbon dioxide is being released by landfills. So your trash will release methane and carbon dioxide. Another impact that humans have on the planet is when we discovered that we could use oil as a form of energy, then this has led to more greenhouse gases. So over the past 200 years, since the Industrial Revolution began, carbon dioxide levels have increased, and the global temperature has increased because we've relied on these fossil fuels. And so as there's more and more demand for energy, the only way that we can get energy not the only way, but one of the ways that we get energy is we'll convert chemical energy into electrical energy. And this chemical energy first comes from light energy. So plants are doing photosynthesis. Plants are storing up in energy, and they're converting it to chemical energy in the form of glucose. Glucose will stay in the plant. The plant will die. The plant gets smushed down. The plant gets compacted. The plant decays, and more plants decay. And over time, these layers and layers and layers of plants turn into a black sludge. That black sludge is called oil. When humans discovered oil and it has untapped energy in it, humans were able to figure out that they could turn that oil and they can burn the oil. And when they burn the oil, they can convert the chemical energy into a different type of energy. They can turn it into kinetic energy to be able to power cars. They can power factories. And they can also power what's called power plants, where chemical energy of oil can be burned and turned into electricity. By turning a turbine, it can make an electric current, and that electric current can be stored or sent out to charge iPhones, to charge iPads, to charge your Chromebook, to charge your TVs. Anytime you need power, the power plant can now supply electricity to you because oil and gas is taking chemical energy and turning that into electrical energy. Now, the problem is that when that is burned, when oil is burned or gas is burned or coal is burned, guess what? It's releasing carbon dioxide and methane into the air. So oil and gas and coal through the Industrial Revolution has sped up the process of our planet getting more and more greenhouses. There's more and more greenhouse gases than ever before on our planet because of the burning of the carbon. When our temperature rises on our planet because of the greenhouse gases, this is called global warming. Global warming is given rise to higher and higher temperatures every year. Now, why is this happening? Well, it's because there's greenhouse gases in our atmosphere. CO2, CH4, water vapor, and others trap in the heat in the atmosphere. And where is the heat coming from? The heat is coming from our sun. Without our sun, there'd be no life on our planet. The sun gives us life. The sun changes light, or not the sun, but plants will use the sun to change light energy into chemical energy. So it's great for our planet in that sense. It also is going to warm our planet. So the sun emits solar energy towards Earth. And this is going to warm up our planet. So I'm going to draw a sun, and I'm going to draw in a sun ray, and that's going to be sun rays hitting our planet, and that's going to warm it up. And we're going to have I drew a little energy bolt. I wanted to show some heat, so I'm going to show that as heat there. So it is warming up our planet in the form of heat. And this is a natural process, and it's completely fine. However, the human impact through landfills, through oil and gas, through the burning of fossil fuels, and now growing more and more livestock has contributed to more and more greenhouses on the planet. So here's the problem. We have more and more greenhouse gases than ever before. The Earth will emit radiation into the planet, and this sun rays will travel towards the Earth, and it'll begin to be absorbed by the Earth in the form of heat. And so our Earth begins to warm up, and the Earth's surface will absorb all of the sunlight. But some of the sunlight isn't necessarily absorbed. Some of the sunlight is reflected. And this sunlight gets reflected back up into the Earth's atmosphere. And as it goes back up into the Earth's atmosphere, I'm going to show two arrows to go back up into the Earth's atmosphere. It's going to hit this layer of greenhouse gases, and the greenhouse gases are going to warm up. But not only do the greenhouse gases warm up, it also reflects it back down to Earth in the form of infrared radiation, and it's going to re-emit this heat back to our planet. So this reflection off the greenhouse gases makes that ray come back to our planet instead of going out into space. If there's less greenhouse gases, the rays can just be deflected off our planet and go back into space, but instead, the sun rays that are emitting heat are getting trapped by the greenhouse gases. And they come back to our planet, and guess what? Guess what they're going to do? They're going to warm up our planet now, and there's going to be more heat on our planet because the greenhouse gases are now reflecting the sun's rays and bringing the sun's back to the planet. And so our planet becomes more and more warm. Planet gets warmer. What's really frustrating is not only is our Earth's surface getting warmer, but if you begin to realize that our Earth's surface is not just Earth's crust, not just the mountains, not just the land, but it's also the ocean. And so these rays can hit the ocean and warm up the ocean, and then they can get deflected by our planet and come back on the ocean. And what is happening with our ocean? Our ocean's going to get the sun rays, and the ocean's going to begin to warm up as well. So as the sun's energy comes through the greenhouse gases, the greenhouse gases are trapping in the sun's energy, and they're warming up our oceans as well. And heat is becoming trapped inside the ocean, and it's warming up the ocean as the ocean absorbs and stores the sun's energy. And this can be really devastating for many of the sea creatures in our ocean. Maybe you've heard about coral bleaching. Maybe you've heard about coral reefs dying off because the oceans are too warm and they're causing acid buildup to kill off the coral reefs. And so if the coral reefs begin to die out, that's going to cause other creatures of the sea to die out because these creatures use the coral as a food source and a shelter source. And so if a creature's shelter is taken away and a creature's food source is taken away, that specific creature will die off. And so there's many creatures that are dying off because coral is dying off. Not only is that taking place, but it's disrupting the food sources of many different animals in the ocean as the ocean heats up. So having the ocean heat up can be very devastating to our planet. Greenhouse gases will trap in heat on our planet in our atmosphere. So I'm going to draw several different heat lines to show that our planet is, in fact, heating up. This heating up of our planet, because there's more and more greenhouse gases on our Earth, is called global warming. Global warming has been on the rise for the past 200 years because of human impact. Because we have more and more livestock than ever before, more and more oil is being pumped out of our planet and being burned, releasing CO2 and methane, from our landfills. Because of this, it's trapping in more and more heat, and global warming is on the rise. In fact, the planet for the past 20 years has been on the rise of about 2 degrees. 1 to 2 degrees every year, the planet is getting hotter. Now, we don't always notice this heat. We don't always notice this heat because what global warming is leading to, it's leading to a process called climate change. Climate change is on our planet, in different zones on our planet, our climate is changing. What we're going through right now is extreme temperatures. One day we might have hot, and another day it might be really cold. This might bring tons of rain at one point in time, and then the other point of time, there's no rains for long periods of time, and there will be drought. In some places, this could cause flooding, or in some places, this can cause intense snow and ice storms. And in other places, it would cause extreme heat. Or the temperatures are going to be wild and fluctuate very differently. For example, we just experienced it this week of climate change. We just saw a climate change event happen this week. On Monday and Tuesday, we had record-breaking heat in the Bay Area for the month of March. In some places in San Jose, it hit 90 degrees on Tuesday. That's never before happened in the Bay Area, where we've had 90 degrees on that Tuesday. That was a record breaker of heat for many parts of the Bay Area. And now, if you look at the temperature, it's swung wildly we're back to cold temperatures. This is due to different events in climate changing. As our planet becomes warmer and warmer, we're going to have extreme weather. It's not just hot all the time. It's going to be hot at some times and very cold at other times. Or we might see intense floods or intense rain being given off. Or we might see snowstorms in areas where we've never had snow. Or it can be completely dry for a while. So the global warming has led to climate change. What's really challenging is that as methane is released into our atmosphere, methane can hold on to the sun's energy longer than it does carbon dioxide, and it can hold more heat energy than carbon dioxide. So methane is more efficient at trapping heat than CO2. In fact, it's 84 times more powerful than CO2 over 20 years. So the greenhouse effect is a natural phenomenon on our planet that gives rise to our atmosphere and allows the planet to warm up. However, as we are burning fossil fuels, as we're having more and more livestock and the more of a need for meat, and as we're throwing away more and more packaging and materialing, and throwing away different food scraps, and we're not reusing these resources, it's causing more and more greenhouses to be released into our atmosphere. What you do on the planet is called your carbon footprint. What you do with your life and how we use our life is a carbon footprint. I hope you have enjoyed making the joy of diagrams today and creating a beautiful setting of greenhouse gas and carbon effect.